Hello my friends and welcome back to the You Can Do TV channel. In the historic casting town of Kuwana, Mie Prefecture, Maruda Foundry Company, Limited continues Japan's proud legacy of iron casting craftsmanship. Specializing in the manufacturing and sales of thin-walled cast iron gas appliances, Maruda is the only company in Japan that handles the entire process, from design and production to inspection and delivery, entirely within its own factory. Casting, the process of pouring molten metal into a mold and allowing it to harden, is used to create many essential products in daily life, from manhole covers to industrial burners. Maruda's specialty lies in producing durable, high-performance gas appliances for commercial kitchens, but their product range also includes artistic cast items like bells, incense burners, cookware, and decorative pieces, all crafted with expert precision. The production begins with mold creation using automatic or traditional molding machines. Next, raw materials are melted in a cupola furnace reaching over 1,500 degrees Celsius. The molten metal is then poured swiftly and quietly into prepared sand molds using ladles. After cooling and hardening, the molds are broken apart and the castings are retrieved. Each piece undergoes shot blasting to remove any remaining sand, followed by inspection for cracks, dimensional accuracy, and surface defects. Trimming machines remove excess metal along dividing lines, ensuring a clean finish. Depending on the product, machining is performed using lathes or drill presses. To prevent rust, castings are coated with protective finishes tailored to their application. One of the most critical steps involves inspecting gas valves, using pressure gauges to ensure airtightness and safety. Finally, each unit is burn tested for performance, and only fully approved products are packed and shipped. Maruda's cast iron products are trusted across Japan, used in restaurants, event stalls, emergency food services, and more. From the casting city of Kuwana, Maruda continues to explore new possibilities in Japanese foundry craftsmanship and shares their high-quality products with both domestic and global markets. In a world driven by packaging, few materials match the timeless elegance and purity of glass. Behind every clear, glossy bottle lies a fascinating journey, one of fire, precision, and transformation. The production of glass bottles is a detailed and carefully controlled process that combines raw materials, high heat, machinery, and inspection systems. It begins with the preparation of a batch, a mixture of sand, silica, soda ash, limestone, and small amounts of other materials. These ingredients are mixed and melted in a furnace at extremely high temperatures, usually around 1,500 to 1,600 degrees Celsius, until they form a smooth, molten glass. The hot molten glass is then divided into equal portions called gobs. These gobs are directed into forming machines, where they are shaped into bottles using two main methods, blow and blow or press and blow. In method, the gob first forms a preliminary shape in one mold, then moves into a final mold where compressed air gives it the exact form of the bottle. After shaping, the hot bottles must cool slowly. They pass through an annealing layer, an oven where the temperature is gradually reduced. This step is essential to remove internal stresses in the glass, making the bottles stronger and more resistant to breaking. Once cooled, bottles go through inspection. Modern factories use automated systems, cameras, and sometimes manual checks to detect cracks, bubbles, uneven surfaces, or other defects. Only bottles that pass this inspection are sent forward. They are then packed in trays or boxes, ready for shipment. Glass bottles are valued for their durability, cleanliness, and recyclability. They are widely used for beverages, sauces, cosmetics, and medicines. The ability to preserve freshness and prevent chemical reactions makes glass an excellent packaging choice. Modern production Lin. The Dacheng DDIEB180X4Z is a high-performance flash butt welding and deburring machine designed for chain links, rings, bars, and flat bars. It uses high-voltage DC current to generate heat at the joint, producing a clean, strong weld. Immediately after welding, the integrated deburring unit removes burrs and sharp edges, improving product quality and safety. This compact system ensures precision, consistency, and efficiency by automating flashing, welding, and finishing in one process, ideal for industrial applications demanding fast and reliable metal joining. High bolt. The journey from recycled scrap metal to finished steel beam begins with electric arc furnace, EAF steelmaking, where raw scrap is melted down to form fresh steel. At the Piener Traeger GmbH PTG plant, beam blanks are produced and transported to a reheating furnace for further processing. Here, billets are reheated and rolled into the specific lengths required for each order. To ensure structural integrity, ultrasonic testing is carried out to detect internal material flaws. Impact resistance is verified through Sharpie impact tests, performed in PTG's in-house laboratory. The next stage is beam processing at Salzgitter Mannesmann Stahlhandel, where cutting, drilling, and material alignment take place. Bolt holes are drilled to accommodate spacer systems and cross-bracing connections. Beams are then shot blasted to a surface cleanliness of SA 2.5 and receive corrosion protection coatings as per Deutsche Bahn DB standards. This may include galvanization and primer coatings up to 80 microns, with optional intermediate coatings applied to 60 microns. The final coating thickness is precisely measured. Once quality checks are complete, the beams, up to 100 tons in total, are loaded and transported to the construction site, taking up to 8 hours. On-site, beams are unloaded, positioned on shifting scaffolds, and precisely installed centimeter by centimeter. KMZ is Hora Metal, specializes in the production of open die forgings and billets using high alloy and heat-resistant steels, non-ferrous metals, and specialty alloys. Equipped with hydraulic presses rated up to 2,000 tons and manipulators up to 10 tons, the facility supports forgings up to 10,000 kilogram. Heat treatment furnaces feature automated controls with plus or minus 5 degrees Celsius stability. Machining operations include roughing and finish cuts using wear-resistant bandsaws and turning centers optimized for difficult-to-machine materials. Integrated ultrasonic testing and Sharpie impact testing ensure structural reliability. Annual production exceeds 9,000 tons, serving sectors including nuclear energy, petrochemicals, and defense, with full certification from Russian maritime and military standards. The hydraulic billet shearing machine is designed for precise and high-efficiency cutting of metal billets into predetermined lengths before forging or rolling operations. It uses a powerful hydraulic system to generate the required shearing force, capable of handling billets of varying diameters and materials, such as carbon steel, alloy steel, and stainless steel. The machine features a robust frame, hardened blades, and an adjustable clamping system to ensure straight, clean cuts with minimal deformation. Advanced models include automatic feeding, length adjustment, and PLC control for continuous and consistent operation. This system is widely used in steel mills, forging shops, and metal processing plants, improving productivity and reducing material waste. With its fast cycle time, ease of maintenance, and safety interlocks, the hydraulic billet shear is essential for efficient upstream preparation in metal forming lines. At the Euro BLECH 2014 Trade Fair in Hanover, Von Schaven AG presented a striking exhibition piece that demonstrated the full scope of its thermal cutting and metalworking expertise. The showpiece was a solid steel block with dimensions of 1,000 by 1,000 by 1,200 millimeters and a total weight of 6,940 kilograms. This massive component served to showcase the precision and power of autogenous flame cutting techniques, along with the company's end-to-end manufacturing capabilities, from forging to testing and final packaging. The process began with Freiformschmieden, or open-die forging. Using high-pressure hydraulic presses, the raw steel was compressed and shaped to refine its internal structure. This crucial step removes voids and internal imperfections, improving both mechanical properties and grain flow. Open-die forging ensures the base material meets strict requirements for the structural integrity needed in subsequent heavy-duty operations. Next, the forged block underwent preparation for flame cutting. The surface was cleaned and marked to define precise contours for cutting. Proper preparation is vital to ensure the flame cutting torch follows accurate paths and produces clean, straight cuts. To start the internal cutting, an oxygen lance was employed to create a pilot hole. This process, known as Entstecken, generates an initial opening that allows the cutting torch to enter the material cleanly and with control. Following this, a 500 mm diameter core hole was cut vertically through the entire 1,200 mm thickness of the block, using autogenous flame cutting. This process requires high temperature and expert control of oxygen and fuel gases. The torch melts the steel at the cut line, while a high-pressure oxygen jet blows away the molten material. With the core removed, the outer contour of the block, 1,000 by 1,000 millimeters, was then cut using the same flame cutting method. This step required perfect coordination to maintain dimensional accuracy over a significant thickness. One of the more advanced stages involved cutting a conical cavity to a depth of 600 millimeters. This shape, more complex than simple vertical or horizontal cuts, required careful manipulation of torch angle and cutting depth, a testament to von Schewin's technical skills in producing non-standard geometries with thermal processes. To verify the quality of the steel and the effectiveness of the process, the finished block was sent to von Schewin's in-house testing laboratory. Here it underwent a Charpy impact test and a tensile strength test, ensuring the component met mechanical and structural specifications. After successful testing, the part proceeded to milling operations. The outer surfaces were machined to final dimensions, improving flatness, surface finish, and overall appearance. This post-processing stage ensured tight tolerances and a professional final presentation. The final task was secure packaging, preparing the massive steel block for safe transportation and exhibition. Displayed at EuroBLECH, this component symbolized von Schewin AG's core strengths: precision forging, advanced flame cutting, thorough testing, and full production control. Through this project, von Schewin demonstrated that even the most massive steel blocks can be processed with remarkable precision, highlighting the company's position as a leader in the field of heavy steel processing and custom-engineered solutions. The DMG bevel gear 14B00022 vs. 04 is a precision-engineered mechanical component designed for high-torque, right-angle power transmission. Manufactured to exacting standards, it ensures smooth, efficient motion with minimal backlash. Commonly used in advanced machinery and automation systems, this bevel gear offers excellent durability and performance under heavy load conditions. Its optimized tooth geometry enhances load distribution and reduces wear, making it a reliable choice for demanding industrial applications requiring long-term reliability and precision. Below. The Tool Factory MR290 milling cutter, equipped with internal cooling and robust WNGX indexable inserts, demonstrates outstanding performance when machining C45E steel. Thanks to its strong cutting geometry, the Mr. 290 is ideal for corner and face milling, as well as roughing and finishing tasks. It ensures long tool life, high metal removal rates, and excellent process reliability. Designed for a wide range of materials, the Mr. 290 delivers high rotational and axial runout accuracy. Its thick, double-sided inserts enhance cost efficiency while providing optimal cutting stability. The cutter supports multiple applications, including slotting, shoulder milling, face milling, and plunge milling. With efficient coolant delivery, KSS/air, and a positive rake angle for improved shearing, the Mr. 290 is a high-performance solution for precision metalworking. The Herco VMX42 HSI Machining Center is purpose-built for high-speed cutting operations, especially effective in non-ferrous materials like aluminum. In this setup, the machine demonstrates aggressive roughing capabilities using Millstar high-performance tooling. The VMX42 HSI features a robust 15,000 RPM inline direct drive spindle and advanced motion control, allowing for precise engagement and minimal vibration at high feed rates. During the aluminum roughing process, Milstar's tool design, featuring variable helix and optimized flute geometry, enables excellent chip evacuation and thermal management. Combined with the high acceleration and deceleration rates of the Herco platform, the process ensures minimal cycle times without sacrificing surface integrity. The integrated WinMax CNC control allows dynamic toolpath optimization, reducing air cutting and enhancing cutting engagement. This synergy between machine and tooling delivers high material removal rates while preserving tool life. Ideal for aerospace and precision manufacturing applications, the Herco VMX42 HSI, equipped with Milstar tooling, showcases the advantages of synchronized high-speed spindle, rigid structure, and intelligent cam integration. Operators benefit from both machining speed and reliability, critical in modern production, where cycle time, dimensional accuracy, and surface finish matter equally. Kennametal delivers advanced tooling solutions to optimize turbine blade machining, supporting both standard and customized applications for the aerospace and energy sectors. Designed to cost-effectively process near-net shape blades, blade roots, and airfoil geometries, Kennametal solutions incorporate indexable carbide inserts, solid carbide end mills, and ceramic indexable cutters. These tools are specifically engineered to handle difficult-to-machine materials, such as high-temperature alloys commonly used in turbine components. The integration of high-performance tooling reduces cycle times, enhances dimensional accuracy, and increases tool life. Kennametal's global expertise ensures reliable performance across various machining operations, including roughing, semi-finishing, and finishing of turbine blades. A comprehensive range of proven tool options enables manufacturers to adapt quickly to production needs while minimizing machine downtime. Additionally, Kennametal's tooling is compatible with high-speed, multi-axis machining centers and is backed by expert application support. This enables streamlined production workflows, improved part quality, and overall process efficiency. By delivering high-precision, durable cutting tools, Kennametal helps manufacturers achieve tight tolerances and maintain consistency in demanding production environments, making it a trusted partner in turbine blade manufacturing worldwide. E-Cheat. The Okuma LBEXMYW horizontal lathe delivers unmatched versatility through powerful machining capabilities, thermal stability, and intelligent design. Engineered for multitasking, it supports Y-axis offset turning, live tooling, and hobbing operations, streamlining complex part production into a single setup. By employing double tool holders from WTO, the LBEX eliminates tool indexing between roughing and finishing passes, dramatically reducing cycle time. This configuration allows threading of both V and Acme profiles, precise Y-axis drilling, and hex milling using Capto face mills. For helical pockets, the turret indexes to perform off-center milling and then chamfers edges automatically, removing secondary deburring steps. Laser engraving on the face-milled surface is achieved with high-speed live tools. The optional hobbing unit, supported on both ends, enables stable spline cutting in parallel to the Y-axis. This dual support reduces deflection and enhances cutting performance. As a fully modular lathe, the LBEX-MYW adapts to complex demands in precision part manufacturing. Electropolishing is a highly controlled electrochemical process used to enhance the surface of stainless steel components. Unlike mechanical polishing, it removes microscopic peaks and embedded contaminants by dissolving a thin layer of metal. By applying DC current in a temperature-regulated acid bath, usually a mixture of sulfuric and phosphoric acids, the process levels the surface at a microstructural level. It not only creates a bright, reflective finish, but also improves corrosion resistance by removing free iron and exposing a richer chromium oxide layer. This process begins by racking parts and immersing them in the electrolyte bath. A direct current is applied, making the parts positively charged, and controlled metal removal begins. Accuracy can reach plus or minus 0.0002 inches. After polishing, parts are rinsed and dried before inspection and packaging. Electropolishing is especially vital for industries such as medical, semiconductor, and food processing, where surface cleanliness, sterility, and corrosion resistance are paramount. Compared to traditional passivation, e.g., nitric or citric acid, electropolishing offers superior corrosion protection, improved surface smoothness, easier cleaning, and enhanced fatigue strength. It's particularly effective for components with complex geometries or internal passages where mechanical finishing isn't feasible. The MBK MSM320B mesh welding machine is a high-performance solution engineered for the production of reinforcement meshes used in flat precast concrete elements, box culverts, and L and U-shaped dry cast concrete structures, such as rectangular pipes. This system enables precise and automated welding of longitudinal and transverse wires, forming durable reinforcement grids critical for structural integrity. Its programmable control unit allows for customization of mesh sizes and welding patterns to meet specific production requirements. In parallel, MBK's wire cage machine is tailored for fabricating reinforcement cages used in manhole components and concrete pipes. The machine forms cylindrical and conical cages with adjustable diameters and lengths, ensuring consistent reinforcement for round precast structures. Both machines offer optimized automation, reduced labor, and high production efficiency, making them vital in modern precast concrete manufacturing environments. The KAB MAK armoring line RS24+32/630 is a high-performance cable manufacturing system designed for armoring and reinforcing power and communication cables. Equipped with 24+32 bobbin cages in a 630 mm take-up system, it enables simultaneous application of steel wires or tapes with precise tension control. The line features automatic wire feeding, programmable pitch settings, and electronic synchronization, ensuring consistent lay length and concentricity. Ideal for medium to large diameter cables, it supports both single and double wire armoring operations. With robust construction and user-friendly controls, the RS24+32/630 guarantees high speed, continuous production with minimized downtime, meeting international standards for armored cable reliability and performance. Aerospace. WECOIL Spring Machinery Workshop stands at the forefront of precision spring and wire forming technology, offering a comprehensive range of equipment engineered for reliability, speed, and versatility in high-volume industrial production. The product lineup includes the Universal Camless Spring Machine Series, Universal Cam Spring Machine Series, and High-Speed Spring Coiling Machine Series, each tailored to handle complex spring geometries and wire bending tasks with exceptional consistency. The Universal Camless Spring Machine Series utilizes a fully servo-driven system, eliminating mechanical cams for increased programming flexibility and rapid setup changes. Independent servo motors control each axis, enabling the precise fabrication of extension springs, torsion springs, and intricate wire forms. The camless configuration enhances adaptability, supporting multi-angle bending, looping, and coiling operations with accuracy across a wide range of wire diameters. Real-time digital control ensures optimal synchronization during high-speed operation, reducing cycle times and minimizing material waste. The Universal Cam Spring Machine series combines the reliability of cam-based control with the simplicity of programmable logic controllers. These machines are ideal for producing tension springs, compression springs, and shaped wires in standardized production environments. The cam design provides mechanical repeatability and endurance under continuous duty cycles. Integrated with high-precision feeding rollers and pitch control, these machines offer superior coil integrity and load performance, meeting strict tolerance requirements. For high-speed volume production, the high-speed spring coiling machine series is specifically engineered to produce compression and tension springs at rapid cycle rates. Equipped with a servo-controlled wire feeding system and automatic cutting unit, these machines ensure consistent coil pitch, diameter, and free length. The intuitive touchscreen interface allows quick parameter adjustments, fault detection, and production monitoring, maximizing uptime and efficiency. Across all models, WECOIL machines are capable of working with a variety of materials including stainless steel, carbon steel, music wire, and alloy wire, accommodating diameters from 0.2 mm to 6.0 mm depending on the model. Optional modules such as inline stress relief ovens, camera vision inspection systems, and automated packaging stations can be integrated to enhance throughput and product quality. Designed for sectors such as automotive, electronics, home appliances, and industrial hardware, WECOIL spring machinery delivers consistent performance, reduced downtime, and superior precision. Backed by comprehensive technical support, operator training, and spare parts availability, WECOIL continues to set benchmarks in modern wire forming and spring coiling technology. In addition to its standard capabilities, WECOIL also provides fully customized machinery solutions tailored to specific production lines or specialized spring configurations. Advanced CNC software integration enables remote diagnostics, production data logging, and real-time process optimization. The Telstar Hummel engine assembly line features a fully automated process optimized for high speed and precision installation of engine components. The operation begins with the automatic positioning of the engine block onto the conveyor system. Robotic arms then sequentially mount major components, such as crankshafts, camshafts, pistons, and connecting rods into the block with torque-controlled tools. Cylinder head installation follows, with automated systems applying sealants and gaskets before precision fitting. Valve trains and timing components are aligned and secured using synchronized servo-driven systems. Further downstream, automated stations mount fuel systems, intake and exhaust manifolds, and belt-driven accessories like alternators and compressors. The lubrication system is assembled with automatic feeding of pumps, filters, and routing of oil lines. Automated manipulators insert sensors and wiring harnesses, ensuring all electrical connections are in place. Throughout the line, robotic stations handle component orientation, bolt insertion, and fastening, reducing the need for manual intervention. Designed for modular flexibility, the Telstar Hommel line allows for simultaneous processing of different engine variants. Its efficient layout, robotic coordination, and streamlined component delivery result in consistent, high-throughput engine production with minimal human involvement. China is home to a robust and highly developed truck wheel manufacturing industry. These manufacturers specialize in producing a wide variety of wheels for commercial vehicles, including tubeless steel wheels, forged alloy wheels, and wheels designed for trailers, buses, and off-road equipment. With decades of experience, access to raw materials, and modern production infrastructure, Chinese manufacturers have become key suppliers in both domestic and global markets. The production process typically begins with the selection of high-quality raw materials. For steel wheels, manufacturers use hot-rolled steel coils, while aluminum wheels are produced from heat-treated forged billets. The steel material is uncoiled, cut, and formed into a cylindrical shape, which is then welded to form the wheel rim. In forged alloy wheels, the billet is heated and then pressed into shape using a high-tonnage forging press, often above 8,000 tons of force, to produce a dense and strong wheel blank. Once the initial shape is formed, the rim undergoes precision flow forming or spinning to achieve its final dimensions and structural profile. Simultaneously, the disc portion is created through stamping or forging, followed by CNC machining to create bolt holes, valve holes, and hub bores. The disc and rim are welded together using automated MIG welding stations to ensure uniformity, strength, and consistent weld penetration. Advanced machining processes, such as vertical CNC lathes and robotic drilling centers, are then used to finalize dimensions and tolerances. Surface treatment follows. Steel wheels are shot blasted and coated using cathodic electrodeposition, KTL, or powder coating to resist corrosion. Aluminum wheels may undergo polishing, anodizing, or painting depending on customer requirements and design preferences. Each wheel is subjected to a series of rigorous quality tests, including radial fatigue testing, bending fatigue testing, impact testing, and air leakage detection. Non-destructive testing, such as X-ray or ultrasonic inspection, is also applied to detect any internal flaws in the welds or forged materials. Chinese truck wheel manufacturers operate highly automated production lines that integrate robotic arms, programmable logic controllers, PLCs, and digital monitoring systems. These technologies not only increase productivity but also help maintain consistency across large production batches. Many facilities follow lean manufacturing principles and adhere to international standards such as ISO TS 16949 and DOT specifications. One of the strengths of Chinese manufacturers lies in their flexibility and capability to produce custom solutions. They offer a wide range of diameters, widths, bolt patterns, and load ratings to meet the diverse requirements of OEM and aftermarket clients. Special designs are also available for mining trucks, port trailers, and heavy-duty logistics vehicles. In response to global trends, many manufacturers are now investing in R&D for lightweight wheel designs and intelligent wheel systems. with embedded sensors for tire pressure and temperature monitoring. There's also growing emphasis on eco-friendly production, including waste recycling, energy-efficient furnaces, and water-based coatings. Overall, Chinese truck wheel manufacturers combine efficient processes, advanced technology, and global competitiveness to supply high-quality, durable wheels for a wide range of commercial transport applications. Their ability to scale, adapt, and innovate continues to strengthen their position in the global supply chain. The Crossbar robot by Schuler, part of the Andritz Group, exemplifies state-of-the-art automation for modern press lines, offering unmatched flexibility and productivity for both new installations and retrofitting existing systems. Designed to optimize metal forming operations, this system integrates seamlessly into various line configurations, delivering maximum efficiency and reliability. At its core is an advanced 8-axis robotic system capable of handling a combined part and tooling load of up to 90 kg. This enables the precise handling of large or complex components. The system supports press operations at speeds of up to 15 strokes per minute, making it suitable for high-output production environments. With an adaptable press spacing of 5 to 10 meters, 197 to 394 inches, the Crossbar robot accommodates varying factory layouts and tooling setups. Key functionalities include destacking of blanks using either hanging or standard robots, loading into the press, and transferring parts from die to die with precise orientation. This ensures minimal cycle times and consistent part quality. The robot's ability to perform double or quadruple part production further boosts throughput. A standout feature is its automatic tooling change capability, allowing for rapid transition between production batches without significant downtime. This contributes to shorter setup times, reduced manual intervention, and higher overall equipment efficiency, OEE. Ideal for automotive and industrial applications, the Crossbar robot reduces labor costs, enhances safety, and delivers consistent high-precision forming. It represents a robust solution that supports flexible manufacturing strategies, contributing to future-proof, sustainable production. Schuler's Crossbar robot redefines stamping automation, streamlining processes while maintaining superior performance and scalability. At Robotic India, the end-to-end manufacturing of smartphone accessories is executed with a streamlined workflow that integrates automation, quality control, and vertical integration. The facility is equipped with an in-house advanced tool room for mold development, enabling the design and precision machining of custom dies and injection tools used across production lines. The process begins in the injection molding division, where high-precision molds are utilized to fabricate plastic housings for chargers, data cables, and mobile phone accessories. Parallel to this, the SMT, Surface Mount Technology division, handles the automatic mounting of electronic components onto PCB assemblies. These boards are then routed to the charger assembly lines, where they are integrated into charger units. A rigorous charger burning and testing protocol follows, simulating long-duration charging cycles to ensure thermal stability, safety, and consistent electrical output. Approved chargers are then routed to the packaging area, where automated packing stations prepare them for market delivery. Simultaneously, mobile battery and power bank production occurs in dedicated assembly lines. Raw materials are stored systematically in climate-controlled environments to preserve component integrity. For data cables, the process begins with wire twisting and bunching operations, ensuring consistent impedance and structural strength. The cable cores then pass through PVC extrusion lines, applying a durable insulation sheath. Post-extrusion automatic connector soldering units attach metal terminals, followed by cable injection molding machines encasing the connectors in rugged plastic housings. Each cable is subjected to electrical testing, including continuity, resistance, and tensile strength tests before final packaging. The production of mobile phone cases is carried out using high-pressure injection molding, producing robust yet lightweight protective shells in various sizes and finishes. For mobile tempered glass, precision cutting, chemical strengthening, and oleophobic coating are performed in controlled environments to maintain surface clarity and hardness. Every step of the process is monitored through quality assurance checkpoints and real-time data logging. ERP-integrated systems manage inventory, job tracking, and batch traceability across divisions. Robotic India's vertically integrated facility emphasizes lean manufacturing, reduced lead times, and product consistency. Its comprehensive in-house capabilities, from mold fabrication to electronic assembly and packaging, enable rapid prototyping, mass production, and fast adaptation to market demands. This smart factory approach positions Robotic as a leader in the Indian smartphone accessory segment, delivering reliable, high-performance products at scale. The BDM 120 to 250 duct elbow making machine is a specialized forming system engineered for the production of round and rectangular duct elbows used in HVAC systems. Designed for precision and efficiency, the machine processes pre-cut sheet metal into elbows, with diameters ranging from 120 mm to 250 mm. It incorporates a hydraulic forming mechanism and CNC-controlled tooling to ensure consistent curvature, tight seams, and dimensional accuracy. The BDM 120 to 250 is equipped with adjustable forming rollers, allowing fast setup changes between sizes and materials such as galvanized steel or stainless steel. Its automatic feeding and clamping system increases throughput while reducing operator fatigue. This machine is ideal for mass production of duct fittings and integrates seamlessly into automated duct fabrication lines. Its compact footprint and durable structure make it suitable for both industrial workshops and on-site fabrication tasks. The HDPE double-wall corrugated DWC pipe extrusion line by Dalian Sunlight is a high-performance production system engineered for manufacturing double-layer corrugated pipes, primarily used in drainage, sewage, cable protection, and infrastructure applications. This line integrates advanced extrusion technology, precision tooling, and high-speed forming capabilities to ensure consistent pipe quality and production efficiency. The system begins with two high-efficiency extruders, one for the inner layer and one for the outer layer of the pipe. HDPE pellets are fed into the extruders, melted, and conveyed through a co-extrusion die head. The molten material is then shaped into a double-wall profile through a vacuum-forming process inside a water-cooled corrugator tunnel, equipped with high-precision aluminum molds. These molds move continuously in a closed loop, ensuring seamless pipe formation and accurate interlocking of the inner and outer walls. The corrugation provides structural strength while keeping the pipe lightweight. Following the forming section, the pipe is cooled in a water tank and cut to length by an automatic cutting unit synchronized with the line speed. Dali & Sunlight's DWC pipeline offers stable performance, user-friendly PLC control, and energy-efficient operation. It supports pipe diameters from 50 mm up to 800 mm and guarantees smooth internal surfaces, strong ring stiffness, and excellent resistance to chemicals and abrasion. The Bailey Industrial RDB500 is a powerful hydraulic tube bender designed for precision cold bending of heavy gauge pipe. Capable of bending 60.3 x 3.9 mm SCH40 stainless steel to a full 180 degrees, it compensates for springback with high accuracy. Built in the USA, it handles pipe up to 88.9 mm in diameter, making it ideal for shipbuilding, oil sectors, and structural fabrication. The APK 550 hydraulic profile bending machine is a heavy-duty industrial solution designed for precise bending of large metal profiles. Equipped with 3 driven rolls and a powerful hydraulic system, it is capable of forming tubes, bars, angles, channels, beams, and custom profiles in steel, stainless steel, or aluminum. The 2 side rolls are hydraulically adjustable to control bending radius, while the central roll remains fixed. The machine can operate in both vertical and horizontal positions to suit production requirements. Advanced control systems allow for precise adjustment of roll positioning and rotation speed. With a reinforced frame, the APK 550 ensures exceptional stability during high-force bending operations, making it ideal for structural steel fabrication, curved beam production, shipbuilding, and railway industries. The system provides high repeatability and flexibility, enabling consistent results across batches. Optional side guides and profile supports further enhance bending accuracy and minimize material deformation, making the APK 550 a reliable and efficient choice for demanding bending applications. The VRM 42003-730, installed at Dodge Offshore, represents a leap in production efficiency and heavy-duty forming capability. Engineered by HAEUSLER, this system features high rotational speed and a fully integrated in-feed roller table, ensuring continuous, precise material handling. Its patented upper and side support design allows for bending diameters up to 15 meters and handling loads of up to 150 tons, ideal for large monopiles and wind turbine towers. It sets a new benchmark for offshore and onshore structural component manufacturing. COMAC, Italy's profile bending machine, model 308CN 3.1 volts, precisely forms and bends half-pipe and limpet coil profiles. Featuring CNC control and 3-roll configuration, it ensures high accuracy in cold forming of stainless and carbon steel components for heat exchangers, tanks, and pressure vessel applications. At the South Edmonton facility of Bristeel, large-diameter seamless steel pipes are manufactured using a specialized thermal induction heat expansion process. This 120,000 square foot plant is the only one of its kind in North America, capable of expanding mother tubes from 14 to 16 inches up to 30 to 36 inches in diameter. Heated pipes are pushed over precision mandrels to achieve the desired size. Rigorous in-house quality control includes hydro, eddy current, ultrasonic, and metallurgical testing, ensuring structural integrity and industry compliance.